Okay, so hello again, everyone. As Fabiano introduced me, my name is Elda Paya, and today I'm going to introduce you and make this tutorial about the language we've been working on, and it's called Socio-Technical Security Modeling Language. As the name indicates, we're working on socio-technical systems. So to give you an idea of what are the kind of systems we're working on, I've taken this example about a traveler, say a visiting researcher coming to the University of Trento to give a talk. What would be all the steps he would take till coming here and giving the seminar? Suppose, first of all, he would have to book the trip to come to Trento, and for that, perhaps he would have to rely on a travel agency, say Cheap Travels. The travel agency, on the other hand, might use certain service, say the Amadeus flight service, to find flight itineraries. And the Amadeus flight service on its behalf can provide the itinerary by interacting with different airlines that offer flights, say Ryanair or Lufthansa. Apart from planning the trip, the traveler might need also to book a hotel since he's coming to a new place. And for that, either he could directly interact with the hotel in the city, or through the travel agency, he could check for room availability and book a place, say, in City Hotel. As you can see, there are a bunch of interactions going on, and the different interacting parties are depending on one another to achieve their desired objectives. Say, when the University of Trento is contacting the visiting researcher to give a seminar, he is depending on the traveler to accept that and to come to Trento to give the seminar here. So, in these interactions, as you can notice, we have human parts, also organizations such as the travel agency or the University of Trento, as well as software systems such as the Amadeus flight service. So when we say socio-technical systems, we actually mean an interplay of social, meaning human and organizations, and technical software subsystems. And the core of how a socio-technical system works is that it is based on the interaction of these involved subsystems. And this interactions defines the system in terms of a network of social relationships, as we said, social dependence. The thing is that for a socio-technical system to be reliable and efficient, you'd have to help its participants to achieve their desired objectives. And to do that, we need to ensure that their interaction is actually robust and reliable. But the problem is that in this kind of setting, the subsystems are actually autonomous. They're all independent and different and weakly controllable. So actually, when the traveler... Can I go back? When the traveler is interacting with the travel agency service, he doesn't really know what kind of flights it will get from it, if it will actually get the cheapest. So it might need to specify what it expects from this interaction. And interaction between the different parties happens through message exchange. So basically, they interact with one another and express what they want the other party to achieve. And mainly this happens because they have an objective to reach, which sometimes they cannot do on their own. So we suppose the traveler cannot book the flights without interacting with a flight service, or he cannot book the hotel without interacting at least with the hotel, or the travel agency that would book the hotel for him. And we have also the software systems that participate in the STS. So the security problem is mainly related to the interaction that is occurring between the involved participants. And we don't have only software interaction, but also human software and human-human. And especially the social part of the socio-technical systems might make their interaction less reliable. And since the subsystems are autonomous and weakly controllable, how can we actually secure such interactions? The idea that we've been using in our work is basically to use contracts to constrain the interaction that is going on between the two parties. And because basically when actors interact, they not only rely for achieving a certain objective, but they also might exchange relevant information that is crucial for them to protect. I'll give you examples about this throughout the the talk. Anyhow, what is important for you to get now is that our analysis of security does not actually just focus on technical aspects, since the type of subsystems we are considering are autonomous and weakly controllable. We have to consider the social part as well. And for that, we've been devising this modeling language to build secure socio-technical systems, which we call socio-technical security modeling language. And for brevity, we refer to it as STS-ML. And in this language, we exploit high-level abstractions to analyze security. And our focus is basically on security requirements engineering. And as I said, when actors enter interaction, it's at that moment that they are worried on what to expect from the other party, and if they have exchange of information, how this information is going to be manipulated. So we allow them to express their needs concerning security when entering the interaction with other parties. And this helps us define why security is needed, because it is related to what the stakeholders want to express and what are the security needs they might want to express. Say, for instance, confidentiality or integrity. For instance, when, what I mean with this, for instance, when the traveler would pass his personal data to the travel agency, he doesn't want his personal data to be changed, and that is related to integrity. On the other hand, he doesn't want this information to be distributed to other parties, so he doesn't want his personal data to be divulged, so he's requiring confidentiality. Through the modeling language, we perform the modeling of such systems so that we can actually build secure socio-technical systems. And since our focus is on security requirements engineering, we derive security specifications once we have done the modeling for the STS under development. So some more detail about the language, still descriptive. I think since you're following RE and OIS, perhaps you've been working with other modeling languages. STS-ML is a role and goal-oriented requirements modeling language. It is a graphical language in which models are built diagrammatically. We have graphical concepts and relations, which I'll introduce throughout the talk. And this kind of language, being graphical and having diagrams built to express the security requirements, is also helpful because it facilitates the communication with the stakeholders. One particularity of our language is that instead of giving you a language in which you build a huge model of, say, a system you want to design and to derive the security requirements for, we separate a bit the concerns, and we offer this feature of multiple views in which one can focus on a certain perspective at a time. And our language supports 3 different views: social, information, and authorization, in which we'll go through step by step. Okay. This figure here gives an outline of the modeling language. The language derives security requirements once having the other views modeled. So as I said, we have different views, so it allows for modeling a technical system, concentrating on different views at a time. And we have the 3 views that I mentioned: social view, information view, and authorization view. All these views together form the business view, in which the designer can express security needs that he has gotten from the stakeholders. So what the stakeholders expect from their interactions to be satisfied. And once the security needs have been expressed and the modeling has been performed, we can derive the set of security requirements that the system has to satisfy. Okay, this can be generic. Anyway, now we'll provide you with the modeling method so that you can actually apply the steps of this method in order to be able to model the system and the scenario that you are working on, and also derive the set of security requirements for your given system. Our method includes a set of modeling activities which are basically related to the different views that we are supporting. So we have 3 different phases in which the modeling goes on. Modeling the social view, modeling the information view, and modeling the authorization view. I'm not going to go through the actual steps here because I provide details in the next slide. However, what is important to keep in mind is that through the modeling activities, we can capture the different stakeholders, their interactions, and the expression of security needs. And once we've gone through all the phases, we check whether the models are complete or whether they need to be refined. One could switch from one view to the other because they also have to be consistent, and the models are refined till the point we are sure that we have captured all the information we need and the security needs that one has expressed. And once the modeling activities are done, then we can derive the set of security requirements. But this activity here is a tool-supported activity. So what you have to do is basically on the left-hand side. So do the modeling of your case studies using the concepts and relations of the modeling language. And then once the modeling is done and the security needs are expressed, we can derive the security requirements automatically, and this is done by the tool. So I'm going to guide you through the modeling methods step by step, going through all the phases now. Here it looks like we have a sequential process. Actually, it is just to give you the idea of what one has to do when modeling the different views, so in the different phases. But of course, one might switch to from one view to the other to have consistent information and to complete the information that is missing. So considering the first phase, as in the modeling method, that of modeling the social view. First of all, when modeling a system, even in your case studies, there are certain participants and stakeholders that you want to capture. So for that, the first step is that of identifying the stakeholders that are present in the organization. And in our modeling language, we do that by using 2 main concepts, that of roles and agents. Once you have captured who the stakeholders in your organizations are, it is important to capture what are their assets. Assets are actually coming in 2 forms: goals that are related to objectives that your stakeholders want to attain, and documents that are a representation of the information that they might possess or exchange with others. And a part of the assets, an important point, is that of interactions. As we said in the beginning, in our example, actors very often have to rely on others to obtain their objectives. So in order to reach their goals, either they might have the capability or they have to depend on others, and we capture this kind of interaction through goal delegations. Whereas regarding documents and the information they exchange with others, the interaction is captured through document provisions. Once we have captured the stakeholders and their interactions, the important part is that of allowing them to express the security needs. So what are the expectations regarding security over these interactions? And since we relate security to interaction, that is why in the social view we allow expression of security needs. So what does it mean identifying the stakeholders? So in this step, you'd elicit all the participants in your given case study of the system that you're trying to design. And as I said, in the modeling language, we allow for 2 concepts, that of role and agent. A role is a more generic term than that of agent. Agent refers to a known, actual, an agent refers to an actual participant that we know at runtime, whereas a role is a more general characterization of agents. And actually, when we are designing systems, probably we do not know who the actual participants at runtime are going to be. So it is often the case that we need to use the concept of role to capture these stakeholders. For instance, in our example, when we talk about traveler, visiting researcher, or travel agency, we do not know whether this visiting researcher is going to be Fabiano or someone else, or the travel agency is going to be Soleneve Viaggio or some other agencies. So for that, we use role. So roles are tourist, travel agency in our given example, whereas agents actually are the ones, the actual participants at runtime that would adopt these given roles, say Bob or Soleneve Viaggi. It happens also that some of the agents that we have in our setting are already known when we are designing the system. Say, in our example, we were considering a specific flight service, and that was Amadeus flight service. So if this kind of information is already known at requirements time, we can capture that in our models. And as I said, an agent would adopt roles at runtime, and we capture that through the play relationship. So Bob, say, plays tourist, and that is the way how to capture agent adopting a given role. An important aspect, as I said, after identifying stakeholders is that of capturing their assets. So the first thing is, what are the objectives the stakeholders have and what they want to attain? And we capture that through the concept of goal. So goal is a state of affair which an actor intends to achieve. For instance, examples of goal include trip planned, flight tickets booked, and so on. To capture how goals are achieved and how they are actually attained, we consider goal refinements in terms of goal decompositions that come in two forms: or decomposition and end decomposition. Or decomposition actually provides alternative ways of how a given goal may be achieved. For instance, when we consider goal tickets booked, possible alternatives to that are train ticket booked if the traveler is taking the train, or flight ticket booked if he is taking a flight to his destination. Whereas when it comes to end decomposition, it actually provides the way how a given goal is achieved. So this is the basic process, because in order to achieve the higher level goal, the lower level goals, all of them have to be achieved. So when planning the trip, the tourist would have to both book the tickets and also book the hotel for planning the trip. Okay, as I said, our stakeholders might have the capability to achieve some of the goals they have, but for others, they have to rely on other participants or other stakeholders. And to capture this transfer of responsibility from one actor to the other to achieve the desired goal they have, we capture that through goal delegation, in which a delegator actor delegates the fulfillment of a goal to a different actor. Say the tourist cannot book the tickets on his own, and for that he relies, so delegates, tickets booked to the travel agency service, TAS. And the way we represent that in the modeling language, graphically, is like this. Another important asset of stakeholders are their documents. Documents represent an exchangeable entity which may contain some information. So basically, they contain certain information, and it is important of us to keep track what information is contained therein. And through documents, there are certain documents actors possess, the stakeholders possess, and they need to manipulate to achieve their goals. And in doing so, there are certain operations they can perform over the information, since an actor might need a certain document to achieve his goal, or he might modify a document while fulfilling a goal, as well as he might produce a new document while fulfilling a goal. To give you examples about these cases, say when achieving goal flight ticket booked, one might produce flight tickets, so that was the Amadeus flight service, might produce the flight tickets when achieving that goal. And in order to book flight tickets, it needs itinerary details, and it might need to modify itinerary details for booking the flight, say, perhaps because the traveler might have requested so. And in order to capture the exchange of information by means of documents, we use document provision, which captures the exchange of information between a provider actor and a providee actor, with the condition that the provider actor should possess the document before providing it, and the providee is an actor that actually might need to use or modify this document to achieve its goals. To capture document provision, we use this notation. So tourist is providing document traveling order to travel agency service. So to give you an idea of how a model in the social view would look like, considering our given example, I've modeled here the social view for the travel planning scenario, in which we have the tourist wanted to plan a trip, and for this he has to book the tickets and book the hotel. And in order to book the tickets, he delegates. So we have a goal delegation from the tourist to TIS for ticket booked, and we have another delegation from the tourist to the hotel for booking the hotel. We express the different needs and modify and produce so the relations between documents actors might need, modify. Okay, we don't have, we should have a produce when achieving their goals, and also the provision of documents such as provision of traveling order from the tourist to TIS, or the itinerary details from TIS to Amadeus service. Okay. Once we have done the modeling and captured all the stakeholders and their interactions, as I said, the important aspect is that of expressing security needs regarding these interactions. And importantly, here in the social view, we allow for expression of security needs over goal delegations. And here I'm going to introduce the three different types of security needs that we support for the time being. The first one is that of no delegation. When a given actor specifies no delegation over a goal delegation, it expects the latter not to redelegate the fulfillment of the goal. Can I go to the next slide? So if we consider our given scenario, when the tourist, say, okay, the travel agency service is delegating flight tickets booked to the Amadeus service, it requires it to not further delegate the fulfillment of this goal to any other actors. And the way we capture that in the modeling language is by representing the delegation line as a dashed arrow instead of a continuous one as the other delegation, for instance, tickets booked. A second security need that we support is that of non-repudiation. The security need is important when the actor delegating to the other wants the second party, the delegatee, not to deny he has been delegated the fulfillment of the goal he wants to attain. So he wants the other actor to accept the delegation is occurring. In our example, say when the tourist is relying on the travel agency service to achieve tickets booked, he's requiring travel agency service to satisfy non-repudiation. So he wants travel agency service not to deny having been delegated tickets booked. And lastly, what the third type of security need we support here in the social view is that of redundancy, which especially for critical goals or goals one wants for sure to achieve, it might require redundancy, because redundancy offers various ways to achieve a goal. And what is important for you is just to keep in mind this kind of redundancy, but it might be interesting for you that we support 4 different kinds of redundancy. So depending on the goal wants to achieve, it might require more ways of achieving it to be executed in parallel, and this is true redundancy. Or it might require that the other party at least has one possible way to achieve the goal, and if that doesn't work out, it has to find some other strategy to achieve the goal. And that is fallback redundancy. And in these 2 types of redundancy, the one achieving the goal might be just one single actor, or it could be several actors at the same time. And that's why we distinguish between single and multi-actor redundancy. Okay. For instance, when the tourist is delegating to travel agency service tickets booked, it might require redundant fulfillment of this goal because he needs for sure to have the tickets. So this is the way we express the security needs over the delegations in the social view. Once we have gone through all the steps of the first phase. Now we next go to the information view, the second phase, so modeling the information view. And this view was created because in the social view we have documents, actors possess, and documents they exchange with one another by means of document provisions. But it is important to know who's this information and how this information is exchanged. So in the information view, we define the information represented by documents, because it is important to keep track which information is actually exchanged when a certain document is provided. And also because information owners are the ones that are concerned about security and how their information is to be manipulated. In the information view, we also represent the owners of different information. And apart from that, in the information view, we also keep track of the information structure by means of two main relationships. Tangible by. The first one is important for the first step because we keep track of which information is made tangible by which document. And secondly, part of is helpful to capture composite information or composite documents. Say we had itinerary details, was an information that included both destination, okay, I'll show here, the information view. So we have captured the different information that are contained in the documents that were represented in the social view. For instance, tourist owns his personal data, and the personal data is the information that is made tangible by ID document copy, which could be the tourist's passport, say, or a copy of his ID card. And at the same time, personal data is made tangible by flight tickets. So it is the case, it could be the case that a given information is made tangible by different documents. So documents that represent or contain this information. On the other hand, tourist owns his itinerary, and itinerary is an information that contains information about destination and schedule. That's why we capture this structure by means of part of. When the tourist is providing traveling order, the traveling order document also contains an ID document copy of the tourist, and that's why we also capture part of between these two documents. So this is the way how in the information view we keep track of which information is represented in which document and how information and documents are structured. An important point when dealing with information exchange and how information is to be manipulated is also to keep track of how one gives permission to others to manipulate his information. That's why after having modeled the social and information view, we go in the third phase, that of modeling the authorization view, in which we model authorizations. So basically the transfer of permissions from one actor to another, where the first actor is mainly the owner of information. So we assume that the owner of information has the rights to legitimately transfer permissions to others on how to manipulate his information. However, he might as well transfer full rights to someone else, making them legitimate to further transfer rights to others. In order to capture these two kinds of transfer of permissions, in the authorization view, we model authorizations about information, specifying these authorizations in terms of three attributes. The first one is scope, and with scope we refer to limiting authorizations in the scope of achieving certain goals. So to make an example, when the customer or the tourist is passing his personal data to the travel agency, he doesn't want the travel agency to use his personal data for everything, or to use this for statistical purposes, or to use it for something that could be profitable to the travel agency. He strictly wants the travel agency to use his personal data only to book the tickets. And it is through this first attribute that we can capture limiting authorizations in the scope of achieving certain goals. On the other hand, when passing rights to others, one might want to specify what are the operations the other party can perform over its information. And the allowed operations are use, that refers to read, modify, produce and distribute. And all these operations we have considered here are actually related to the relationships that we had in the social view. So use refers to the need relation from a goal to a document, modify refers to modifies, and produce the same, whereas distribute refers, since we capture exchange of information by means of document provision, distribution refers to allowing someone to distribute or provide documents that represent information for which you are allowing distribution. And the third attribute, transferability, captures what I said in the beginning. When one wants to give full authority to someone else for a given operation, then it allows him to further propagate rights to other actors, and this is specified by means of this attribute, transferability. Okay. So here I represent the authorization view for our given example, in which we keep track of the information inherited by information view, in which, because since authorizations are passed from the information owner, we keep track of this information. So tourist is the owner of his itinerary and personal data. That's why he can authorize other actors. So he authorizes travel agency service, and the authorization is this line here, and we have 3 different slots. So what are these 3 different slots? They actually refer to the attributes, so the allowed operations one can perform on the information: use, modify, produce, and distribute. The second slot refers to the information for which one is passing authority. So tourist is actually authorizing TAS to use his personal data and itinerary. And the third slot refers to the scope. So here we specify the goals for which one is authorized to manipulate those informations. So the actual authorization taking place here is that the tourist is authorizing TAS to use his personal data and itinerary to achieve tickets booked. And for the last attribute, that of transferability, the way we capture that is through a continuous line. So when having a continuous line of authorization, one can further transfer rights to other people for the authorization has been given. That is why we have this authorization taking place here, even though TAS is not the owner of personal data and itinerary that are owned by tourists, since he's given the right to further transfer or propagate these authorizations, he's actually passing these rights to the Amadeus service, with whom he's interacting to get flight tickets booked. So he's passing the authority to use and produce itinerary and personal data in the scope of flight tickets booked. On the other hand, we assume here the tourist is directly interacting with a hotel to book the tickets, and for this, he's passing the hotel the authorization to use his personal data in order to achieve hotel booked. Okay, when we have modeled the authorizations and have specified what we expect the other party to comply with in respect to how the information is to be manipulated, in a way we are expressing certain security needs of how we expect our information to be used, modified, produced, or distributed. So differently from the social view in which we represent or express security needs explicitly over goal delegations, here in the authorization view, we express security needs implicitly by allowing or not allowing certain operations and limiting the scope. So when limiting the scope in a certain goal, we actually are expressing a need-to-know security need. Can I go to the next one? Okay. So I guess it is better to give you the visual part of it. So when limiting the scope of a given authorization in that of achieving certain goals, the tourist is requiring TAS to respect need to know, because he wants the TAS to strictly use his information only for ticket books, not for any other goals. On the other hand, as I said, by allowing or not allowing certain operations over information, one is expressing other security needs. So, for instance, when usage is not passed, which is not the case in our scenario, we would have a non-usage security need. When modification is not passed as an operation, as an allowed operation, then a security need of non-modification of this information is expressed. And similarly for production and distribution. So when tourist is authorizing hotel for using his personal data, he's actually expecting hotel not to modify, not to produce, and not to distribute his information for any reason. So with this step here, we also finished all the different phases and modeling the different views that we have, social, information, and authorization. As I said, the modeling activities are iterative, so the modeling process may continue because you might need to refine the views. There is certain information that you want to include, new security needs that you might want to express, and so on. So the views can be refined, and of course changes in one view have effects on the other views. But what is important is that then when you have arrived to a certain point when you think that your models are complete and you have captured the security needs you want to express, then from requirements models, we would pass to requirement specification. But as I said, the modeling activities you will perform will be up to this stage. This is just to give you the flavor of how we derive security requirements and how security requirement specifications could be later used for designing secure socio-technical systems. Because requirements models are useful to communicate with stakeholders. Given that they are visual, graphical models, it helps communicate with them whether we have captured what they need, all the information that they want to express, and all the security needs they want to express over their interactions. And that's why, basically, these are information you have in the case study or a security analyst would elicit through interviews. Whereas the requirement specifications tell designers what the system has to implement in order to satisfy these security needs that were actually expressed. And in our language, as I said, this is an activity that is automatically performed, so security needs are automatically derived from requirements models. How we do that? In STS-ML, we support the derivation of security requirements in terms of social commitments, because security requirements, or the security needs actually that we express over the interactions, constrain interaction in terms of contractual terms. So these contracts are actually expressed as social commitments. What is a social commitment? This concept is used to capture promises that actors, stakeholders exchange with one another. So it is a promise with contractual validity that one actor makes to another, that a state of affairs will be brought about if another state of affairs holds. To give you an example, don't get lost with these details, what is important is to have an idea of how we capture security requirements once the modeling is done and the security needs have been expressed. So a commitment would be from my part to University of Trento or to Paolo and to you all, that if the tutorial is scheduled, then a talk will be given with respect to this modeling language. How are actually commitments capturing security requirements? When we have this certain commitment, it is related to a given interaction that is taking place and to a specification that if the tutorial is scheduled, then a talk will be given. So me, Elda, that is making the commitment, I'm actually responsible to bring about this commitment, and UnityN, here, the party to which the commitment is made, is the requester of such state to be brought about, and the requirement is that a talk will be given provided that tutorial is scheduled. So this is how we map the commitments to an actual form of requirements that we have in the modeling language. So a responsible would commit for the fulfillment of a given requirement to requester. And these requirements are actually expressed for every security need that we support in our modeling language. And I'll show you how we derive the security requirements for every expressed security need. When the tourist is, like, as I said, the security requirements are strictly related to the interactions that one have, and since we express security needs over delegations and authorizations, the main sources of security requirements are actually those where the security needs are specified. So when the tourist is specifying non-repudiation over its delegation of tickets booked to TAS, it expects TAS to make a commitment on tickets booked for non-repudiating the delegation of tickets booked to the tourist. And when it is specifying, when the TAS is specifying no delegation, when delegating all flight tickets booked to the Amadeus service, it is expecting Amadeus service to commit for not further delegating this goal to any other party. So in our form of requirements, the security requirements we can derive from this is that TAS is responsible for bringing about the requirement that was requested by the tourist, that if the delegation from the tourist to TAS of tickets booked occurred, then the TAS will not repudiate this delegation. On the other hand, for the no delegation from TAS to Amadeus service, then the responsible actor to bring and to satisfy this requirement is the Amadeus service. And the requirement is requested from the travel agency service that if the delegation occurred, so delegation from TAS to AS of flight ticket booked, then AS will not further delegate this goal to any other party. In a similar way, we would automatically derive all the security requirements in terms of social commitments for all the given security needs that we have specified in the social view, and I've listed them here in this table. Similarly, since our second source of security requirements is from the security needs specified in the authorization view, whenever we have expression of the security needs, say when the tourist is requiring need to know of his personal data and itinerary for tickets booked, it expects TAS to respect the thing, so that we'll use personal data and itinerary only for tickets booked. And when TAS is requiring non-modification of itinerary and personal data of tourists, Amadeus service is responsible to achieve that, and so on. So some requirements that we can derive from this modeling and expression of security needs are these. So, okay, I've given here the example of the hotel. So the hotel is responsible to not disclose personal data when the tourist is authorizing him on his personal data in the scope of goal hotel booked, and he's authorized the hotel only to use this information, but not to disclose it. So he has to make a commitment, so to respect this requirement for non-disclosure, and he also cannot transfer his rights to any other party. On the other hand, the first example that we were taking was that of need to know, when the tourist was requiring TAS need to know when authorizing him to use personal data in the scope of ticket booked. So TAS is responsible to bring about the requirement that he will respect need to know of using this personal data only in the scope of tickets booked. And similarly, AS, so Amadeus service, is responsible of bringing about the requirement that he will not modify itinerary, given that TAS has authorized him only to use and produce this information, but not to modify it. Okay, as you see, I've given just some ideas of how these requirements are derived, but a bunch of them were not expressed in the slides, so the list of complete security requirements that we can derive from the authorization view would be this one. So for all the operations that are not allowed, we would have a given security requirement automatically derived, and also for all the need to know. So that would be the complete list. So with this, we would finish all the application of our modeling method, comprising the modeling activities and the automatic derivation of security needs. How can we actually use the security specification that we have in modeling a secure socio-technical system? This is just to give you an idea, not that you are going to use this for the application of the method. So basically, when we are considering a system, each participant would be developed independently, and for each participant, the applicable security requirements depend on the role they will be playing or the role that they want to adopt. For instance, if we consider the travel agency service, then we would consider all the security requirements this travel agency service would have to bring about. So the implementation of TAS has to ensure that the delegation of tickets booked will not be repudiated, personal data will not be modified, it will be used only to book the tickets, and the itinerary will not be further distributed, and so on. For all the security requirements, the travel agency service is responsible to bring about, so that participants at runtime actually know what are the things they're responsible to achieve when adopting a given role. So depending also when one is a role or an agent, for instance, in the case of the Amadeus service, which is an actual agent that we already know when doing the modeling, for other parties that would have to interact with him is some kind of guarantee that this agent already in our models had made the commitment to respect and bring about the security requirements to the interacting parties. So it is a further guarantee that they actually what can expect with the interaction with the Amadeus service. Okay. So in order to support all the modeling activities that you have to perform, there is a case tool of the socio-technical security modeling language, which we call STS tool. And this is the modeling analysis support tool for STSML. It is built on top of Eclipse. And importantly, after you perform the modeling, so apart from offering you the drawing, utilities, canvas, and all the concepts and relations of the modeling language, also performs the automatic derivation of security needs. And more details will be given by Fabiano in the next presentation. Okay, thank you. So if you have any questions, any doubts, okay, so